Go and open your book to page 675. Today's lesson, this is the first lesson on the matrices. So the objective is to learn and apply matrix terminology. So first, let's go over what is a matrix. Okay, a matrix is a raw array of information or array of items. Array means you have rows and columns. So example of that would be, so if you look at example, so these are examples of matrix. Again, you have rows and columns. So these are two rows going across, right? So this is the first row, second row, and the up and down are columns. So this is the first column, second column, third column. Okay, and also the dimensions. This is you always name the row by first, then column. So this is 2 rows by 3 columns. So this is 2 by 3. This would be 3 by 2, right? Because you have 3 rows and 2 columns, so 3 by 2. This would be 2 by 1 matrix. Okay, this would be 1 by 3 matrix. And the next thing is the next definition is element. Okay, elements are the entries in here. So each of these is an element or entry. So the 2 by 3 has 6 elements, right? So 3 by 2 has also 6 elements or 6 entries. These are 2 elements or 2 entries. This one has 3 elements or 3 entries. Okay. Now, if the matrix has only a row, then it's called a row matrix. So like this is example row matrix. It has only 1 row. Okay. The column matrix would be example has only 1 column, like this one over here. Okay. The next one is a square matrix. The square matrix is when the matrix is square, like 2 by 2, 3 by 3, okay, for example. So the rows and columns are the same, okay, have the same amount. The next term is zero matrix. Zero matrix is when all the entry in the matrix are zeros. Like this one, this is a zero matrix of 3 by 4. So example, to write it out, so when you have the zero matrix of 3 by 4, that means you're going to get, so you got 3 rows and 4 columns. So this would be the zero matrix of a 3 by 4 zero matrix. Okay. When you name a matrix, you always use capital letter. Okay, it's like capital O, capital A, capital B to name a matrix. And the matrix, the 2 matrices will only equal if the corresponding entries are equal. So like if you look this one over here, these 2 are equal because of these. See, the corresponding numbers are equal. So 1/2 equal to 2 over 4. 4 is equal to 4. 1 is equal to 2 over 2. 2 is equal to 2. And 9 over 6 equal to 3 over 2. 5 equal to 5. So every matching entry or corresponding entry must be equal in order for the matrix to be equal. These 2 are not equal because 3 and 3 match, right? 1 and 1 match. But notice 2 and 7, right? They don't match, right? 7 and 2. Notice it's got switched. So they are not equal. Okay, so to be equal, they have to be exactly the same. So that means you can use that knowledge to solve problems. So if you look at the example, okay, you have 5a, 2b plus 8, you got 0 and you got z. And this is equal to 10, 0, 2, negative 4. So basically what you have is you have 4 entries, right? Or 4 elements. So basically what you have is you have 4 equations. The purpose of matrix is to try to able to condense a lot of information in a easier, a simpler format. Okay, so this one, all you have to do is match. Remember, in order to be equal, they have to all match, right? So that means 5a had to equal to 10, right? And this one, 2b plus 8 had to equal to 2, right? 0 is equal to 0 already, so you don't have to do anything. This one over here, z must be equal to negative 4. And so this is the answer already. This one you divide by 5, so 8 equal to 2, right? And this one just do regular solving, so minus 8, so 2b equal to negative 6. Divide by 2, so b equal to negative 3. Okay, so again, it's very simple. Okay, you just match up the corresponding numbers. Okay, and then after that you can solve. Okay, so let's go and do some practice.